Allow us to introduce the main telescope at the Grove Creek Observatory. Housed in our 3.2 metre 10 feet dome is our massive Celestron c14 pictured here. This is our main viewing instrument, and with a focal length of 3,910 millimeters, this telescope is used for high resolution objects. Being a Schmidt-Cassegrain type of telescope provides a higher contrast than even larger Newtonian telescopes can offer. The C14 was built in 1971 and was the third model ever made by the Celestron Pacific Telescope Company. Celestron Pacific is now just named Celestron. Its 36 cm 14-inch primary mirror is of exceptional high optical standard. In fact, it went beyond testing equipment that could measure an accuracy of 1/10 of a wavelength of light. The C14 at Grove Creek has its own fame, as many live astronomical objects were recorded with special video cameras attached, including live images of the Shoemaker-Levy comet hitting Jupiter that was shown throughout the world in July 1994. Well over 10,000 people viewed Halley's Comet through this telescope when it was installed at Grove Creek in 1985. Here you will find a diagram of how a Schmidt-Cassegrain telescope operates. These types of telescopes are folded optical designs. The light comes through the corrector lens at the front of the telescope to the primary mirror, which then reflects the object back to the secondary mirror, and then through the baffle tube to be magnified at the eyepiece at the end of the telescope. This means that the telescope can be 3 times shorter in physical size. A problem inherent in Schmidt-Cassegrain telescopes is the way that they are focused. They are usually focused through a focuser attached to the primary mirror. At Grove Creek, to stop images smearing, we actually lock our focuser and use a secondary focusing mechanism, which we'll show you later. In the olden days, one had to look at 2 different physical setting circles on the C14 to find a celestial object. This was very time consuming. Now we have a device that all you do is point the telescope at a known star, tell this device what star you are looking at, and then it will know the telescope's position. This is known as a digital setting circle, and our digital setting circle system, the wildcard Argo Navis, has over 64,000 objects in its memory. If the object of interest you would like to see is not in its memory, the device connects to the PC in the control room, and then you can just select the object from a catalogue of billions of celestial objects on the computer. Then the device will guide you to point the telescope to your requested object. Viewing through the C14 is usually at the top of the list of the to-dos for people to come to Grove Creek. However, many people come here for our dark skies to take astrophotographs. Astrophotographs are just photographs through the telescope of space. As we mentioned before, the primary mirror of the Celestron C14 can be locked, and then we put a secondary focuser on the end of the telescope where we can achieve fine focus. This stops the telescope moving and causing stars to smear. As you can see here on this picture, we have a 35mm camera connected at the prime focus of our C14. Fine focus is achieved by the 2 silver knobs you can see in the picture. For wide field astrophotography, you can use our C14 as a guiding platform. We have a Losmandy dovetail set on the telescope, which many different instruments can be attached to. Seen here in this photograph is our Pentax 100 SD UF 4-element 10 cm astrograph, which is a 4-inch f4 refractor. Connected to the end of this is a large format 120mm SLR camera. In fact, this configuration has taken the best photographs at Grove Creek and many of these photographs have won international astrophotography awards. To enable our visitors to take prime focus astrophotography, or astrophotography straight through the C14 telescope, we put an 80mm refractor guide scope on our Losmandy system. Attached to this guide scope is an auto guider. In the olden days, one had to look through a reticle or a target eyepiece and keep a star in the middle by moving the joystick back and forward. Now our ST4 S-Big auto guider will automatically guide the telescope, so it's simply a matter of closing the shutter, having a cup of coffee, coming back, taking off the shutter, and your photograph is complete. You will also notice on top of the telescope that we have an SLR piggyback adapter, and this allows very wide field images to be taken through a normal 35mm camera. Many different piggybacking options have been tried in the past, and this one is a very sensitive video CCD camera that was mounted on top of the C14. To take high resolution CCD images of planets like Saturn and Jupiter, we have a ST5 S-Big CCD camera. To be able to locate the objects with ease, we use a flip mirror pictured here to look through the eyepiece, center the object, and then flip the mirror up to allow the light to pass through to the CCD detector. To take photographs of deep sky objects like diffuse nebulae and galaxies, we use the ST9XE CCD camera. The ST9 is also fitted with an adaptive optics A07. The A07's function is to look at a guide star, and if that guide star moves for any reason, is to tilt the mirror to make sure that the resulting image that goes into the CCD camera is crisp and clear. This now brings us to the end of the tour of the C14. Please join us at Grove Creek to have your nights on the telescope.